Okay. Good morning, good afternoon, my friends. Thank you for your patience. If you were, or if you has been waiting for this stream, thank you for your patience. Last week it didn't happen. This week, despite some troubles on my side, some issues, we are here and we can continue. You can see on my screen in the KiCad schematic editor, there is the finished. I hope I can see that the schematic isn't finished, but almost finished schematic of the isolated 4 to 20 milliamp current loop receiver. It came from the datasheet of this optocoupler, as I showed last time. I can show you this week as well. Let me copy the link. Yes, here. So here is the datasheet of the optocoupler, and in the almost at the end of the datasheet, here it is the receiver circuit. I desperately want to test it because sometimes the only resistor, single-ended resistor receiver is too simple. So I redraw it for the usage of the hardware design template. I added the 𝗲𝗚𝗃 at the end with the voltage reference. I had to add the 4 mounting holes as usual. 3.2 with pad, grounded pad as always. I hope you know my hardware design templates maybe better than me. And what we need to add is the you can see my OCD. There is the resistor, address setting resistor, and there are mounting holes, and the mounting holes are not allowed horizontally with the resistor. So yeah, this way is how the schematic should look like. And it's not everything. The ground symbols must be aligned as well, horizontally, not horizontally, vertically. Yeah, I know I'm sick, but it makes me happy. Benny Devices logo, as always. I2C resistors are there. The current loop connector and the system connector. Aha! Last time I ended with the system connector, but the stream was not working well, so you didn't hear me. Now we want to, or we need to connect on the system connector 3.3 and ground. I2C, IRQ, this is 5 in total. Yes, I think 5. I think 5. Here is VCC, which is not correct. There must be 3.3. So we need to recalculate the resistor as well. I'm going to place it here to not forget. And now I will continue with the system connector. Header as always, 5-pin header. And we set 3.3 ground and 3 I2C related wires, signals. Yes, this way, ground, 3.3, and we want to place the ESD diodes. because the system connector will expose the signals to the outside world, and we need to protect them, protect the signals. ESD 3.3 ESD diodes, small package diodes. I started not showing the the value, because then without the value field the symbols take less space in the PCB, which is always a benefit. So now we have 4 ESD diodes for all but ground signals. The resistor, the power supply voltage is 3.3. We have here 2.5 voltage reference, and we need roughly 1 milliamp going through the reference. So it means that at the resistor, at this resistor, connecting the 3.3 to the cathode of the voltage reference, there will be voltage drop of 0.8 volt divided by 1 milliamp is, if I'm not mistaken, 800. Let me use the calculator to be sure. Yes, 800. 800 is not in the normal range. I don't know how the range is called, E24 or I don't know. Yeah, I think, or 12. I don't know, like the tolerance range of the resistors. So I will use 820, or we can use 750. I can check. I am going to check my library to save time. I don't want to. I have both. And it seems that 820, yeah, both are equivalent. So to have some headroom, let's use this one, but I started changing my Farnell part number codes. Yeah, to be precise, this is not Farnell part number. This is some daughter brand part number. I don't even know how they call it, but I started to using the universal part numbers by Yageo, Samsung, yeah. So whenever my habit is, whenever I touch the symbol that doesn't contain the universal, I mean, as I said, the part number that is not connected with some brand of a distributor, but with some independent like Samsung, Yageo, I don't know, you name it. Yeah, you will see in a second on the G-key. So whenever I touch such a symbol, I always change the manufacturer's order code and adding the datasheet of it. So now we need to find 0603 750 ohm resistor here. So something like this, but we have to be careful. Why? I made this mistake. Sorry. I made this mistake in my life multiple times. What mistake? Here you can see. I hope you can see. Yeah, I can make it bigger. You can see that there is 0603 imperial, which is the 0603 as we want to use, as I want to use, and there is 0603 metric, and 0603 metric is 0201, awfully small, tiny, teeny. Yeah. Like smaller than Airbag, or I don't know. So we have to be careful. You always have to, when we usually, I don't know how you, but I always, when I say 0603, I mean imperial dimension. So this is the package we want. Sometimes when you use the searching at the G key, it gives you like, yeah, the search phrase was 750, but I was given 50 and 750. So you have to be careful that, yeah, the result of your search doesn't need necessarily to be precise. This is something I want to add, but see, there is 0 in stock. I don't know why, but it is. Another one from Yageo is here. A different, I don't know what is different in between these two types. Yeah, 5%. Okay, we want 1%. 1%. Yeah, it's important to check as well. 0 in stock. It takes the marketplace as in stock, but I don't want to use the marketplace. Components. This one. 1%, 750, 0603, plenty on stock. Here is the you can't see my screen fully, but I'm using the paste application that allows me to like improve the clipboard. Yeah, the system clipboard. So I can copy whatever number of items, and then after a special short key I can like pop out these items one by one. So this is what we want, 750, okay. And I noticed that even 802 is not search entry and resistance. Let me do it because it will be quick and it will save my time in the future. Apply all. Yes, 0 as well. I'm chasing Yageo. 1%, this one. Copy. Okay, and this one here and here. Okay, fair enough for now. And let's change this symbol to 750, including the value, and we don't want to update field size and positions. Okay. Yes, I can see that system connector, mounting holes, logo, voltage reference, the input section. I guess we are ready for the annotation. Okay, now the schematic is annotated. Yes. Okay. Now it's time for electrical rules checker. I always encourage you to perform ERC before you switch to PCB. Why? Because the ERC is your companion. It's not almighty. It can omit some issues sometimes when two signals are not connected, but like together, but each of them is connected somewhere, but you want to connect them together. For instance, it doesn't find such mistakes, but a lot of mistakes it can find. So ERC, let's start with errors. The usual suspects are the power related findings. It means that the power input ports are not supplied from the output power pins. It's easiest to solve is by adding the power flag, telling KiCad or telling the ERC that this particular symbol is or place is the power output. Here as well, and I can see a lot of orange arrows, means that copy or the instance of the symbol doesn't match the copy, doesn't match the library. This is why the schematic is 1 week old or even more than 1 week, and in the meantime I started changing the part numbers. So the easiest is to update all symbols in schematic. So I called my shortcut, but if you don't know how, go to properties, update symbol from library, and then there is the checkbox or the radio button at the top item is update all symbols in schematic, and this is what we want. So update, and now all symbols were updated. Sorry. Now we can recall the ERC. 0 warnings and 0 errors. I don't remember what were the findings before, but probably all were connected with the older instances of the symbols. So fast review again. Here is the current loop going through the LED of the coupler. Don't be mistaken. Here is the plus input. So here is the positive side. Here is the anode, cathode. This the arrow on the collector on the emitter. Here is the collector going to the negative point. Here is the like shunt resistor. Yeah, the operation amplifier. Here is the Zener diode. Yeah, it can work. You can see that the optocoupler is somehow special. It has only 1 LED and 2 light sensitive devices. So this is what makes it special. Yeah, I think we can go to the PCB. Let me check comments on the LinkedIn. No new comments. Yeah, here I am. So I'm going to use the split screen mode as always to enable you seeing everything. Now I can update the PCB from schematic. Okay, here are all our components. And you know what I'm going to do as first. Disable the silk screen, disable the values. Yes, it can be enough for now, and switching to 0.5, grabbing first mounting hole, placing it somewhere, switching to edge cut layers, because I want to start with the top edge of the PCB and the left edge of the PCB, and then I will place the components like rightward and downward from the anchor, which will be made by the top left corner. And as you can see, there is still an issue with the KiCad. No, I think I placed the I think I'm too fast. I think I placed the mounting hole before I changed the grid to 0.5. But the issue is that, come with me. Yeah, it's the center is somewhere off grid, and you can see now. There is no way how to align it. There is no menu option like in the schematic, which tells align items to grid. This is missing in the PCB, and the only way how to align it with the new grid, or the usually coarser grid, is to edit the position manually. Yeah, it's not perfect, but what can we do? Here is our point. 4.5 will be the distance of the this is the I forgot. This is the other way. We could use the position relative tool. So I should have saved my time calling directly the position relative tool using the point. Anyway, I've shown you two ways: by editing the position manually and using the positive relative tool. Now we have this section, which is section like the industrial side, the dangerous side, the harsh environmental side, call it as you want. And these components will be grouped. I selected them in the schematic, and now by pressing P, which is how it's called, pack and move. This is one group. The other group is like the other side of the optocoupler. It means the op-amp, ADC, and the voltage reference. The second group, this is the optocoupler. We have the systemic connector with the diodes. This is another group. Usually I place the system connector on the right side, and I think there is nothing bad with it. I will keep this. This, let's say, strategy, and usually I place the I2C resistors on the near the system connector, and now the current loop input connector. This time I will place the system connector like the header unpopulated on the final PCB, and probably use the cable hooks or hook grabbers, or how to call it. We have new comment. Hi, Dinesh Kumar. I'm not sure if I pronounce your name correctly. Yeah, there is a way how to edit the shortcuts of or hotkeys of the KiCad. You can go, or you have to go to KiCad settings. Here is the section of hotkeys, and here are every possible hotkey you can edit. For instance, I've shown you the update. So it was update symbols. This is my shortcut. I use the same shortcut for updating symbols and footprints. So here you can edit any shortcut. For instance, if you want to add new, double click and then edit your hotkey. If you don't want to hit escape to escape. Yes, that's how it works. Let's continue. And yeah, I think in the middle will be the optocoupler because it's the somehow central device with the I will go from the pet number 1, the transistor, the emitter of the transistor. Yeah, I want to copy the like the shape of the schematic even in the schematic in the PCB layout because it will make the understanding of the circuit and debugging and testing easier. So think like this. What else do we have? We have the Zener diode just after the resistor.
Head over to brain.fm or follow the link in the
Let's
description.
go closer. This is the op amp driving the base of the transistor. Oh, sorry, I missed it. I lost it. Here is the op amp driving the base of the transistor. We have to place the coupling capacitor for the op amp close to the pin number 5, which is near the transistor. Here is the Zener. Here is the resistor. Here is the Zener diode. Basically, connecting both sides of the current loop. Here you can see that the current closes through the Zener diode as well as the main path is through the transistor LED of the optocoupler and back, but as well through the Zener diode. The decoupling capacitor of the Zener diode here. I think this component layout will be a working version. I will make some customization because I want to create a good looking PCB, not a piece of a mess. Now the components around the op amp, these 3, this symbol and this one. Yeah, basically all the components that were not placed yet. So this is the integration capacitor between pins 3 and 4. Can be placed here. It means that I will move the op amp a little bit to the left. I want to let the op-amp breathe. It means not to create a crowded area, just to yeah. Simply said, yeah, to keep some area around the footprint. And here from pin number 1 to the negative input of the current loop. I will test the board intensively. So the other aspect of keeping the space around the components is that I most likely will change the values of the components. So it means soldering and non-soldering of the components. So the more space around the components we have, the better. Now you can see there is a nice crossing, but this is what it is. Yeah, I will keep it this way because this allows me to make the PCB smaller, which is not a goal to make the PCB smaller, but smaller PCB means smaller hardware design template, which is the final task for this project, and it means less expensive device for your usage. Here is the output op-amp of the coupler. So let's grab all its components and let's place them where they belong. I almost always start with the coupling capacitors of each IC, because it's important to place them the first time while there is enough space for them. The worst thing you can do is to forget to place them and then to intensively find spot for them. It's not the correct way. These two resistors are in series, so they will be placed next to each other. This is the feedback resistor from pin number 4 to pin number 3 of the op-amp, so somewhere below. With enough space around, I can access both the resistors from the side. This is exactly what I want. Yeah, even the coupling capacitor can be a little bit further. And here is the yeah, here is the we can call it integration part of the resistor of the feedback network. You can place it like this to keep some symmetry. Oh, not symmetry, the schematic is not symmetric, but neither the PCB layout or component layout, but yeah, to be placed there around the coupler. Yeah, probably like this. Now the output register of the op-amp from the pin number 4. Ideally, I will place the ADC below this entire thing. It's highly possible that I will swap the inputs. Yeah. By default, I connected the output of the op-amp to the input 0 and the 2.5 volt voltage reference to input 2, and as well the ground input. It means you can measure even the ground potential. But if it means that the tracks should be cross each other, I will swap the pins at the IC to the state where the signals are not crossed, and it will happen definitely, I think, because you can see 4, 5, 6, 7. Yeah, here are the inputs, so I will place it like this. Better maybe. And the input will be 5, pin number 5. The voltage reference will be, I don't know, maybe on this side, number 6 or 7, we will see. Definitely I will place the 0 ohm resistor on the left side of the IC. The coupling capacitor, as I said, I can see that near the pin number 8, where is pin number 8? Here is pin number 8. Yeah, something like this. Now the voltage reference thing. Now I will place it somewhere here. In the final device, there is the isolation barrier, and now I'm thinking that I can keep this barrier even in the demo design. So probably I will rotate the place it even below. Yeah, back to the comments. How can we mark the do not populate in schematic? Go to the schematic, properties of the symbol, and now cross do not populate. Checkbox. Now the symbol is marked as not populated. I don't like the component layout at all. It's like The issue is that I copied too much of the schematic and forget to keep the place the components like natural way. There will be some crossings, but yeah, schematic must be the layout must be better. Yeah, something like this. The isolation barrier will be kept here. This empty space is killing me as well. I'm not happy. I'm not happy with it. I don't mind this space. There will be the name of the word, the logo, and other things, but yeah, maybe this way. Oh, I don't know. Maybe. Yeah, the other selection. This is the fixed address bit and the configurable. No. There is only one address selection bit, okay. So there are two. Yeah, the description will be below. That works. Here's the pull-up for the interrupt line. It can be placed here and next to the address selection bit to share the 3.3 side. It's always better for the routing. Now what I don't like is this totem. If we imagine that the isolation barrier can go from where I am in, the isolation barrier goes like this. We can place the system connector below. I don't know. Maybe we can. I always recommend to place the ESD diodes in the same direction. It means the cathodes facing the same edge of the PCB, because it's better for the pick and place machine. You save some time in the... Yeah, this is the hardware design template. It won't be placed by or using the pick and place machine, but for the future, I think it's good to keep the good habits, not switch like different habits for the prototypes and different habits for manufacturing. There is another. Yes, yes, definitely. Thank you. Yeah, properties by E. Yeah, I forget. Thank you, Camilo. I forget to say that the properties is hitting key E, or in the contextual manual here, properties. Right click mouse, right mouse click, right mouse button click, and properties. Yes. And these two are the pull-ups for the I2C. Can be placed near the system connector or somewhere here. Here are the inputs. So I will place it. I think I will lead the traces, route the traces for the I2C on the bottom layer. So I can place the resistors here with some nice vias near the left pads of the resistors and share the 3.3 side. Yeah. Please give me a chance to make a short break. If you want, if you like what I want, not what I want. If you like what I do, you can visit 𝗜𝗶𝗀 platform. There are two courses, two tutorials, two courses. One course for beginners, and the second one is for more advanced users. In the beginners tutorial, you will learn how to design this power supply board, including how to create symbols, how to create footprints, how to capture the schematic, how to edit or attribute, how to lay out components, how to route tracks, everything, copper pores, everything, how to upload the graphic logos, things like this. And in the course KiCad for Makers, you will design something like this, or yeah, the same board, or you can, of course, you can change the the shape, the layout. But if you follow the course, you will design this. Two dual-core MCU Raspberry Pi RP2350A, M2 connectors for node cards by Blues, two power supplies, two USB Type-C connectors, bunch of LEDs, 4 power outputs, 4 analog inputs, bunch of other things. Please check 𝗜𝗶𝗀, KiCad for Makers, or KiCad for Beginners. Now, please give Thank you for your patience. I'm back, and we can continue with the PCB layout. So we have 4 mounting holes. The distance in between is 41.5, so I think we can place it 42. From this one, yes, the bottom left, somewhere here, the distance is about 30, so 30 from the top one is the anchor reference, item. And now the bottom right is this one. Yeah. Now I want to create the shape of the PCB. So for using the shape modification tool, I want to create a fillet, and the issue is that the initial shape must be rectangular, not the rectangular collected from four lines, but the rectangular object. So I had to delete the 2 lines and redraw a rectangular instead, and I placed the via here to remember, or not to remember, to anchor the top left corner. Then I used the shape modification tool, right mouse click, shape modification fillet, and I used the same distance as was this mounting hole from the corner. In this case it was 4.5 millimeter in each direction. So this can work. I can place the system connector closer to the board edge, something like this. And if I can, shortly there will be our logo, but it's enough time for it. How it looks in 3D. Not bad. Not bad. It's a test board. It's a prototype. This resistor, I think I will move closer here. This is the coupling resistor. Capacitor, yes. This is the input. Yes, this will be like this. This is something. Yeah, from the other side. Okay. I think I will slightly compromise the isolation barrier, but it's not a point of this board. The point is to verify the schematic. Now we are in the middle of the job today, and in front of the PCB layout, we have to edit the board setup. The 2-layer setup will be 2-sided layout will be used. I want to use the ENIC as copper finish because it looks better in the renders, and as well the PCBs are much better. Constraints I can keep all of them. I will use normal vias of 0603. Now the predefined track thicknesses. Yeah, I think this is enough. Net classes, yeah, this will be our default via size. Clearance 0.2 default is okay, and track default track width 0.2. This will be the thinnest track of this device. Okay, then we can start. So this is the negative input. Yeah, I'm looking at the schematic because I don't like this crossing. Yeah. Let's make a try, and if it works, I will keep it. If it won't, I will redraw it, okay? I don't like this VR. As I said, for the price of compromising the isolation barrier, which is not our goal, you can draw it like this. It means that there is the visible loop and the thank you for the question, but I'm not sure if I understand correctly. What do you mean by what do you mean by the anchor point stickiness? Ah, you mean why the there is one thing you can mean. This is the snapping to graphics, which is, I think, somewhere here. Editing options, magnetic points, snap to graphics. I set it in the config of the KiCad as always. It doesn't work. It doesn't always work well, but most of the time, and the majority is bigger than, or the ratio is bigger than 50%. So yeah, I keep it as always. But I desperately want a hotkey for that, to able to disable snapping to graphics, because sometimes it snaps like crazy, even especially when the components are close together. And I can check if there is a hotkey, but in the previous version there wasn't this hotkey. Snap objects on the active layer only, on all layers. Toggle snapping. Frankly, this is something that doesn't work. I don't know how to use it. I played with it for quite a long time, but I didn't make it work. If you know how to do it, please give me a comment. Nothing awfully, not awfully, nothing beautiful, but nothing awful. Yeah, this is the input of the op-amp. These are the, what is this? Yeah, the gain, feedback gain resistors, feedback network resistors to be precise. Number 2 is power supply, number 1 is the positive input, okay? You know what? I will add a 0 ohm resistor here because it allows me to change the circuit without scratching the PCB, which I hate. I don't like it. Now we're changing the inputs. Number 6 will be ground. It will stay as is. Number 7 will be 2.5 volt. Number 7. And number 4, yeah, number 5 will be the input. Yeah, the crossing is. Oh, if I avoid. If I swap these two inputs, I can avoid the crossing possibly. Let's see. Yeah. I don't know. I need more space for the viscosity lines. I have to start with them. You can press W, which sets the thickness. I can show you in the settings. Here, switch track width to next, W, and shift W is like backwards. So yeah, you can see now I'm pressing W, now shift W to the thinnest and W to the thickest. So you can change even the existing track. For instance, now when you press the U, I think it's the default hotkey for select here, select expand connection. So when you select one segment, press U, it selects the more. The more you press, the more it selects. Yeah. When you press I, it selects the entire net. When you select U, it adds more segments. So, for instance, you want to set this track to the thinner. So Shift, select the entire track by pressing U, and then you can change the thickness of the entire track. Thank you for the question. I'm using the thick track when connecting the pins of the connector because there can be some forces when you place the wires on it, and it can tear off the track. So always use the thickest possible tracks, and don't forget that even the other side of the component must be routed with the thinner wires, like not this way, because this way would most likely cause the thumb stone effect. During the soldering, one side of the resistor would go up. If you make the connection like similar, yeah, it's up to some testing, but most likely this will work. And when one side is too thin, it means that it will be heated up faster. It means there will be imbalanced forces on each side of the component, and the component will go up like this. Okay, now it saves me a lot of troubles to change the layout of the pinout of the header, and as well I have to change the resistors, and I'm using this trick. I change the name of the reference designators and update the schematic, and it will update even the nets for me. You can see now there is no crossing. I only want to connect the 3.3, which is not a big deal. Okay, there is the D. The D is, I don't know, Let me find it. I don't know how to call it. The drag, probably drag. Here, drag 45-degree mode. Yeah, so when I grab the segment, I can move it. Yeah, D is 45 degrees. G is the free angle. Don't use it. I don't like tracks beneath the IC, but this is pretty safe. I think I will remove this. Somewhere here. There is enough space for labels, and we are rather close to this. 3.3 and 3 point. Like this. Now, the copper pore, the segment, the polygon, not polygon, polygon on the bottom side will be ground. Thermal relief, reasonable clearance, yeah, filled with ground. This is why I placed all ground vias. Now I have to connect the 3.3 thing. Not this way. Yeah, this point is rather far from the input, but I think I will use the bottom layer.
For unlimited listening, head over to brain.fm or follow the link in the description below.
Okay. Yeah, this crowded space is always an issue, but I don't know how to do it less confusing. Like this. I will use the labels for the address selection bits, signals. I will use, well, yeah, I will use the labels instead, marking the address feature. It's confusing. I have to change it. Done. Yeah, you can see now how the snap to graphics works. Sometimes you have to zoom in or zoom out to make it work better. For the labels, I always use the 𝗞𝗶𝗖𝗱 plugin, and you can use like this, and it acts like an arrow. Yeah. With one exception, that this is not. This is current. Negative, this is current. This is current negative. Yeah. Sometimes the plugin doesn't work. I don't know why. Now it works. Now the circles marking the pin number 1. The easiest way is to draw a filled circle. I think we have only 2 ICs. You don't need to there are 2 ways. You can use the standard text tool, which is here, text from the menu. You can create a label and you can check the knockout, which is that it will be in version like this. But this is the standard standard label. You can play with the fonts. Yeah, it can look pretty good. Or you can use the 𝗞𝗶𝗖𝗱 plugin. This is 𝗞𝗶𝗖𝗱 plugin. You can find it in the KiCad standard. Yeah, where it is. Here. Close it. Plugin and content manager, and it installed 𝗞𝗶𝗖𝗱 here. It's a standard. You can find it directly from this without changing the repositories. And this is what I used for the labels. So just for the sake, especially for this feature, you can change the leading and ending shape of the label. Yeah, it can be circular, it can be like slash, like this. It can be like arrow, and this is why I like it, because it can work like arrows. So a knockout for the standard texts, changing as well with changing the font, because the standard font is not very nice, but it can work as well. So this way. Now it's time for DRC. I always call DRC after the labels and reference signatures are placed. Why? Because the incorrectly or the scattered labels, the scattered reference signatures cause a lot of warnings, and you won't only deal with the important ones, not the random ones. This is pretty good. Unconnected items 0, it means that we have the connected board, and only single warning. You can see the bright green arrow here, and this is overlapping of the select screen objects. I overlapped them by intention because I don't want a gap in between them, and you can see select screen overlap. It's not a big deal. I can wave it out, delete all markers, and I know about you. So the board use the bottom layer 𝗶𝗶𝗀, which handles the reference plane, and the top layer there is no 𝗶𝗶𝗀 because I don't need it. There is always short connection with, not short connection, the shortest track to the ground, which is on the bottom, and we only use like 3 or 4 tracks on the bottom, which doesn't compromise the quality of the reference plane. I think we are done. And Yeah, obviously no stitching wheels are needed because there is no ground copper pore on the top layer. So yeah, the board is done. 1 hour and 40 minutes, including a short rest and a lot of speaking today. A lot of talking. Okay, I can see that these labels can be slightly improved because they are too thin, and I don't like the standard knockout option because it's too primitive, I don't know. How do you like it? I don't like it. 𝗞𝗶𝗖 can create better labels. There are some issues, just a few fonts. Sometimes it doesn't work perfectly, but my overall feeling is it creates nice looking labels. So I think we are done for today. Thank you for being here. Thank you for watching. I am happy that my new camera, it's not a new, I have it for like 1.5 years, but I always have used or had used my phone as a camera. But last time the stream failed because I had to pick up a call and the stream didn't like it, and I couldn't continue with the stream, so I had to conclude it before I wanted to. So this week it worked perfectly. The camera works well. The field of the camera is bigger, but I don't think it's a big deal. Thank you. I don't want to like talk nonsense. Yeah, the board's not so bad as it looks at the beginning. I think it's ready to be manufactured. Test it. I already ordered the components today because I ordered components for other projects. We have new comments. Thank you, Ahmed. See you next week. Next week on Thursday, the same time. Thank you a lot. It means a world to me that you are here and communicating and commenting the stream. So anytime, next week, the same time, on Thursday, interactive, so you can ask anything and I will immediately answer. There is a short delay between your comment and my reaction because there is like delay when the StreamYard, which is platform I'm using for streaming, display the comment, but I think it's I don't know, a minute or even less. Thank you again and see you next week. Bye bye.